So good morning, good afternoon, good evening to everyone here dialing from around the world. I'm happy to kickstart the I4E webinar on renewable energy generation and green hydrogen. My name is Ling. I'm the Director of Communications and Marketing at ARE. So as I said, welcome to the Innovation for Electrification Showcase webinar. It's organized by ARE. So the background behind the webinar is that we created it so that our members can get one step closer to potential collaborators. And this gives them the opportunity to directly showcase their products and solutions. So with that, I'm happy to kickstart this edition of the Renewable Energy Generation and Green Hydrogen edition. Now, you might have noticed that the topic is part of a wider campaign that we launched in April. So yesterday, we launched a newsletter on the same theme. So you can check out the contributions from some of our members there. And as you can see, here is the agenda for today. We'll be looking at different types of technologies. We'll be looking at high altitude wind energy from SkySails, electrification financing from EDFI, river hydrokinetic power systems from ORPC, green hydrogen from H2 Energy, nanogrids from Power-Blox, and last but not least, we'll be having we'll learn about battery replacement for CNI users in Africa, and all of this will be moderated by my colleague Deepak. Kindly note that the session will be recorded. The recording and the presentation will be made available on the ARE website. So if you do have any questions, feel free to drop that in the chat and with the name of the speaker that you'd like it to be addressed to. So for those of you who don't know us, we are the Alliance for Rural Electrification, ARE. We're the global association for the decentralized renewable energy industry. We represent over 200 members. You'll see some of them here in the webinar. And they come from more than 55 countries and work in 3 continents. So this is a slide about the members' regional focus and expertise. As you can see, most of them work in Africa, but we also have members working in Asia and Latin America. So what's important to know is that at ARE, we federate all types of different decentralized renewable energy technologies and system sizes. As I mentioned, we have 200 members, and out of those 200, 150 of them work with solar PV, 40 of them use wind energy. We have about 30 companies that work on bioenergy, 45 on hydropower. We have 100 offering energy storage solutions. And last but not least, we have 11 members involved in developing and implementing green hydrogen solutions. So you'll see some of them here today. And yeah, this is my last slide. So we at ARE, we offer 4 membership service lines. The first one being business and market development. We have capacity building as well. The third one is policy and advocacy. And the last one is communications and marketing. So if at the end of this webinar, you do have some questions on how to join, feel free to reach out to us. And with that, I'd like to wish everyone that's tuned in an insightful webinar, and I'd like to hand over to my colleague Deepak, who will be facilitating the webinar. Thank you.
Thank you so much, Ling. Good morning, good afternoon, good evening to the dear audience dialing in from all over the world. Welcome to the Innovation for Electrification Showcase webinar. My name is Deepak Mohapatra. I'm the Senior Officer, Business and Market Development at the Alliance for Rural Electrification, and today I will be facilitating this webinar from this point onwards. As my colleague Ling has already provided you the background about this webinar, as well as the organization who organizes it, so Alliance for Rural Electrification it is, we have the pleasure to invite our prominent speakers who are the subject experts of the current topic of discussion, which is renewable energy generation and green hydrogen. With that, we would move over to the speaker invitations, and I would like to stress on the fact that all the speakers will have up to 10 minutes for their presentations. So dear speakers, please stick to the time. And dear audience, please use the question answer function of GoToWebinar in order to ask your questions. So please pay attention to all the presentation being made by the experts and be ready with your questions. While asking your questions, please make sure that you are naming the speaker that you're asking the question to, so that I can then redirect those questions during the question answer round to the speakers. So with that, thank you so much, and I have the pleasure to invite Mr. Norbert Taphorn from SkySails to do the first presentation. Norbert, the floor is all yours.
Thank you, Deepak, for the introduction. Perhaps we can start the presentation. Yes, very good. SkySails Power offers airborne wind energy systems, and I want to explain a little bit what it is and what we are doing. This is a picture from Germany, typical picture when you drive over the land and have a look. There's agriculture on the ground, trees in the background, and you see overall classic windmills. The main question is, what is with the area about these windmills? Who is harvesting the wind higher than the windmills? And that is exactly what we are doing. Next slide, please. We from SkySails are focusing on heights of 200 to 800 meters, where we harvest the wind with our kite solution. How does it work? We bring a kite to 200 meters. Then the kite starts flying figures of 8 and produce very high pulling forces on the tether. By pulling out the tether out of the ground station, in the ground station, a winch starts to rotate and produce electricity. Reaching the end of the tether is normally 800 meters long. We make something the kiters called nose diving. We reduce the nose, and with this we have no flying options anymore for the kite, and the kite is nearly falling down to the ground. We have, with very low energy, to rewind the tether, and at 200 meters it opens up to the nose and starts again with the cycle. This is a power cycle, and as you see here, next slide please, we have two phases, the power phase and the return phase. In the return phase we need a little bit energy, but we produce much more energy during the production cycle. How does it look like? We have different things. First of all, the kite. The kite is normally 180 square meters big. We have under the kite you can call it a drone or an autopilot and control pod who is steering the kite. We have number 3, the tether, I mentioned already, 800 meters long. We have number 4, the launch and landing mast that helps us to come a little bit in the wind. This mast is normally 25 meters high. We have the container. Inside of the container are some components I will explain later. And we have the foundation, and that's a big point for us. We don't need big installations of concrete. We have just 3 plates in Germany in our test facility. The plates are just 2 meters of 2 meters and 40 centimeters deep. So the foundation is very small. Inside the container, we have, of course, the control cabinets that control everything about the system, and the winch with the gear, with the generator and the gearbox. And through the bottom of the container, we go with the energy and have the energy supply. Next slide, please. We are the first company in the airborne wind energy field that has an external certificated power curve. You see here this power curve. This is shows that we can generate up to 100 kilowatts of power, and with this power curve at a good wind side, we can generate more than 400,000 megawatt hours a year. That's not the end, that's just the beginning. we want to increase this power output to 200 kilowatts. That is something our engineers working on step by step. We become closer to the 200 kilowatts that we want to do. Next slide, please. What are we doing for the moment? We have the PN14 system, a 200 kilowatt system. I mentioned it. With this, we are focusing on diesel grids, hybridization of diesel grids, where the energy price is very high. This is quite necessary as we not have a mass production at the moment. With this, we can reduce the price of the LCOE, and that will happen when we go to the next phase of our system. Also with the PN14 in onshore wind farms, installing some kites in parallel to each other. And really big step is coming when we think about bigger systems. Perhaps a megawatt system is the idea of our engineers at the moment. Then we can go to levelized cost of energy lower than 5 euro cents per kilowatt hour. For the moment, we are more in the area of 20 euro cents per kilowatt hour. But even with this, there are many projects where the diesel generation costs are much, much higher, and where we can have a positive impact to the generation costs also with the existing system. Next slide, please. Yeah, that's for the moment a big opportunity, a new possibility, and we are not really fighting against the other renewables. I think we are another possibility. If you have in your project not enough space for solar, if normal windmills are not possible, or the small ones not effective enough, if there are any problems with the energy supply, just think about us. Perhaps it can be an alternative for us. We are just at the beginning at this new technology, and looking for project opportunities where we can work together with you as a project developer, us and the project owner, and look how we can use our systems. Next slide. That was it already for questions. I'm here later on in the Q&A session. Otherwise, write me, or the phone number is also working with WhatsApp, Line, WeChat, whatever. Thank you very much.
Thank you. Thank you so much, Norbert. Impeccable timing. You have finished the presentation in 7 minutes. So dear other speakers, you have some scale to match up to. All right. Thank you, Norbert. For the next speaker, may I invite Mr. Quentin Deho, Senior Investment Officer at Fee Management Company. Quentin, the floor is all yours. Similarly, you have 10 minutes. So let's start. Thank you.
Thank you very much. Thank you, Norbert. That was very interesting. It's the kind of solution you would only dream of when playing with a kite. It's good to see that you bring this to reality. So moving on to EDFI Management Company and the Electrify facility that we are managing. Next slide, please. So EDFI Management Company is a company that has been created 8 years ago, or anniversary is tomorrow actually, by 15 European DFI who wanted to create development finance solutions that would enable them to invest in more risky and higher risk projects. So we are our shareholders and active members are the DFI from Europe. And EDFI Management Company is managing a range of development finance solutions that start with the Agrify and Electrify facility, but we also manage guarantees and co-financing instrument. In this presentation, I'll focus much more on Electrify. I'm Senior Investment Officer for this facility, so that's why. Next slide, please. And well, the next one directly, please. Yep.
Just a moment.
There might be a technical glitch, but Quentin, carry on.
Yeah, of course. what we are investing basically where others cannot invest. So EDFI is a closed-ended facility with a clear focus on access to energy. We are investing in early stage companies and projects. We're financing the private sector only. We are aiming at creating new connection or improved connection to a clean and reliable energy. Adding new generation capacity is also something that we are very much focused on, again, with sustainable source of energy. And really important, we are active in all emerging markets with a clear focus on Africa so far. Most of our investments are in sub-Saharan Africa, but we have also investment in Asia, for instance. Something that I didn't mention and which is clearly very important is that the EDFI facility is a program that is funded by the European Union. So we are investing funds from the European Union. When I say investing, it's really important. It's not a grant or a kind of concession financing. It's really an investment facility. Next slide, please. What we have been designed for is to invest in early stage company, as I said. So if you see this kind of curve, is a typical curve that any company would go through. So you have an idea, you have an incubation, then you prove the concept, and then this initial growth is really difficult to finance. The incubation, well, you have probably access to grant or some kind of very concessional funding, but once you've tapped into the grant for 4, 5, 6 times in a row, at one point in time, you need to move on to not yet commercial funding, but probably DFIs or multilaterals. But then you need to have a certain size to attract larger funding. What EDFI is doing is investing in this initial growth to allow for the company to reach a stage where they can scale operation and attract development finance institutions or multilateral to finance them until they come to a stable operation and probably can start to attract also commercial finance. Next slide, please. What are the eligibility criteria to apply for funding from EDFI? So as I said, it's definitely renewable energy. We are quite broad in the type of business model that we finance. So we finance solar home distribution company, connected power plant, but also captive power plants. We finance quite a lot of mini grids, CNI systems also, and then others. We also looking at clean cooking stoves, energy efficiency project. The idea is really to have a clear link to renewable energy or energy efficiency. So we invest in early stage project, but we need to see something that is commercially viable. So we need a proof of concept and also a viable business plan that we will challenge. So definitely the commercial viability of the project is important for us. We are not financing development costs, for instance. We are very much focused on the ESG standards. So we follow the IFC performance standard to make sure that we are aligned on all aspects of environmental, social, and government aspects. Track records, so that we need at least a bit of track record, but that comes also with the commercial viability of the project. And what can we offer? Well, because we are very flexible in the structuring, because we can offer senior loan, but also equity and everything that stands in between. We'll invest a ticket of 0.5 or 1 million up to 10 million euro, but we cannot finance more than 50% of any commercial round. So we want to co-invest and catalyze also private investments. Next slide, please. So we are really focused on impact. That's definitely what we are targeting. So we want to see new connection. We want to see generation of clean energy. That's really the most important aspect of our investment. I'll pass this slide a bit further, a bit quicker, please, so I can move to maybe some example also. As I said, that we are mainly active in the southern sub-Saharan part of Africa. We have a global facility that has been invested since 2017, as you see in the bar chart. But on top of that, we have two families of country windows. You can see the name of each country there. So that's where we focus our investment for the moment, and we continue to deploy quite actively over the years. Next slide, please. This shows a bit the portfolio that we have today at the end of 2023. So we have about 60 transactions in 50 different projects or companies. The breakdown of business model, well, as you see, it's mainly solar home system and small power plant, but also mini grids is a quarter of what we've financed so far. When we take the instrument equity, quasi-equity, and junior debt form 2/3 of the entire financing that we do, because definitely we want to be catalytic and de-risk any investment for the co-investor. So we tend to take more junior position. And yeah, geography, definitely sub-Saharan Africa is the biggest part of what we finance. Next slide, please. And that's over the impact. As I said, the impact is definitely really important for us. We track the 2x challenge, so the employment, the involvement of women in the project, being at the management level, at the shareholder level, but also as customer. That's really important. The number of beneficiaries, the avoidance of CO2 emission, and also the catalytic effect. So far we have leveraged 4.2 times what we've put in investments. Next slide, please. So that's the first example of what we finance. Nuru is a mini grid operator in DRC. Which we financed them during the COVID crisis, and also a bit before that, in fact, during the Ebola crisis and outbreak in DRC. We committed 1.3 million euro with co-investor adding up to 2.5 million euro. And this enabled Nuru to build this first mini grid project. The company continued to develop and face very, very difficult challenges, nearing bankruptcy at some point in time, but we were really there to help. And in the end, it ends up being a very good story, because thanks to our early stage and catalytic investment, Nuru has now attracted over 35 million euro in additional investment over the last 4 years, and is now a very significant actor in the mini grid sector in DRC. Next slide, please. So Usk Power System is another investee. They're much more active in India, but they have also a bit of a track record now in Nigeria. They are a leading provider of decentralized energy. We have invested in 2022, and in 2024 an additional 4 million were committed, and now Usk has secured a significant amount of 96 million additional funding. So this exemplify all the early stage investment implication of Electrify can unlock a cascade of financing and promising DRE company. And last slide, please. So Systema Bio is a bit of a hybrid company. Well, not hybrid, but very special, because they are manufacturing biogas digester for small scale farmer. They've been created in Mexico first, so Latin America is the first market, but they have now expanded in East Africa and South Asia. We have invested since 2019 and in several rounds. Now Systema Bio is looking at Series C and has been able to secure 24 million almost of additional investment. So that's also a very good story that we are very proud to have been part of from the beginning. Next slide, please. So that's coordinate. Don't hesitate to reach out on the website of EDFI MC company, and also on electrify.eu, or reach out to me directly. Thank you.
Thank you. Thank you so much, Quentin, for your insightful presentation and providing us the info about how EDFI is creating, or EDFI is creating the impact on the ground in real time. Dear audience, please do not hesitate to ask your questions by pointing at the speaker, so that during the question and answer round, I can take and redirect those questions to the speakers. Thank you, Quentin, for your presentation. Now we will move over to the next speaker, Mr. Brendan Cahill, Director of European Development, ORPC. Brendan, the floor is all yours, and you got 10 minutes. Thank you.
Great, thanks Deepak, and yeah, pleasure to speak to everyone, and thanks to EDFI for organising this webinar with some great speakers. So yeah, very pleased to introduce everyone watching to ORPC and our technologies focused on river and tidal energy applications. We're developing multiple systems, all based off the same cross-flow turbine design you see in the images here. So next slide, and I'll introduce you to the company. So ORPC is a US company headquartered in Portland, Maine, but we also have teams and subsidiaries in Canada, Ireland, and Chile. And as I said, we're focused on developing technology and projects that harness the power in free-flowing water, so be it from rivers, tides, estuaries, also downstream of hydroelectric facilities. And with we're looking at a particular market entry opportunity in remote and off-grid communities, which is obviously the topic of the webinar today. So next slide, and I can talk to you about some of the areas we're located in. So as I said, we've headquartered in the US, and a lot of our activity so far has been in North America, in the US and Canada, strong presence in Alaska, but we are expanding with a global presence. Later this year, we'll be installing our first project in Ireland, and we're also preparing to install our first device in Chile at the moment. But we've had inbound outreach from around the world, and we're very keen to develop partnerships and explore opportunities in any area that has fast-flowing rivers and tides, where there's a need for decentralized renewable energy systems. So next slide, please. So for the focus of this webinar, I'm going to talk about our RivGen system. This is our most advanced river energy system. This is a unit that's rated between 40 and 80 kilowatts, depending on the flow conditions at the river it's deployed in. And depending on those flow conditions, the velocity of the river and any seasonal variation, this can generate between 200 and 600 megawatt hours a year, with quite a high capacity factor possible if the flow in the river is very consistent. And in an off-grid setting, with where energy usage is low, this can potentially power hundreds of homes, providing a very steady baseload source of power, low footprint in terms of land or river space usage, and also importantly, it coexists very well with fish and other aquatic life. So thanks for turning on to the next slide. I'm happy to talk about this now. This is our flagship project in Alaska. We're working with a remote community called Igiagig. This community is located 400 kilometers from Anchorage. There's no road or grid connection, and the community had been reliant on diesel generators, with the fuel being flown in light aircraft or transported by barge, so they had a very high cost of power. So we've had devices installed at Igiagig since 2019. In September of this year, we started operating 2 devices for the first time, all as part of a microgrid that we've developed in collaboration with Schneider Electric. So we've been able to operate through some very challenging conditions. We get ice, we get debris. I'll just stay on this slide for one moment. And also we've been able to operate in harmony with the surrounding environment. The river we're deployed in is one of the largest sockeye salmon runs in the world. We've been doing a lot of environmental monitoring with state and federal agencies and universities. Through that period, we've had over 100 million juvenile salmon pass our turbines, over 10 million adult salmon, and we've observed no fish injuries or fish mortality. So we've been able to demonstrate with our turbines installed, we have no impact on that marine life, which we think is very important and a key advantage of our system. We'll move on to the next slide, please. This is the type of microgrid system we've developed at Igiagig, but which we would hope to deploy in more communities around the world. In this case, we're looking at a system based around 2 turbines and combined with a smart energy system and energy storage. This allows us to relegate the diesel generators to backup only, but also it sets a really nice template for connecting with other forms of intermittent renewable energy like solar PV or wind, where we can get some complementary effects from the very steady output from a RivGen system, combined with the more seasonal or fluctuating power from more established technologies like wind or solar. So we're very keen to investigate opportunities to do more integration of these technologies. Next slide, please. So I think one of the some of the points I want to emphasize in this presentation is why we think this system is very suitable as a power solution in remote and challenging deployment locations. I think firstly, these systems rated between 40 and 80 kilowatts that can be very modular, decentralized sources of power. We can deploy them as individual devices or in arrays of farms where there's higher power requirements, let's say in larger towns or commercial or industrial settings. As I mentioned before, we've been proven to operate in very challenging environments. Difficult Alaskan winters, very cold temperatures, ice and debris, and there's different challenging environments at other locations, but we've been able to operate successfully through those conditions. And also very importantly, we've developed the system with ease of logistics in mind. All our components can be shipped in standard shipping containers, and then the assembly, the installation, and the operations and maintenance can be done with small teams using local teams, equipment, and skills. And I'll talk about that in the next slide, is showing maybe the life cycle of a project as we move on to the next slide, please. So these are just some pictures of us deploying our device in Alaska. You're seeing it transported, and you can see the type of equipment we're assembling the device with on the beach. We're not doing it in an industrial facility. It's been shipped there, ready to be assembled, lifted using standard construction vehicles. Small teams can be being used to do this with only a handful of our ORPC team supporting the operations. And if we move on to the next little slide, I'll show the device being installed. You'll have seen the device, it has those very distinctive blue pontoons it sits on. That allows us to float the device out to the deployment site using local vessels. If we look at other forms of marine energy, the installation vessels used to install the devices at their anchors are very specialist, very expensive. They're not going to be accessible in remote communities. So we have designed a system that can use local vessels to install the device. We then sink it to the riverbed where it's operating out of sight, out of mind, but operating very consistently, across the year for 24 hours a day. Next slide, please. One of the other advantages then of the system is the environmental benefit. We worked with a university in Ireland, Queen's University Belfast, who published a peer-reviewed paper in an international journal, which was a full life cycle analysis of our project at Igiagig. This showed that the project has a potential to reduce the carbon emissions from the community by over 98%, and that's including the manufacture and transport of the device. And this is saving the community millions of litres of diesel a year. So this is obviously a significant cost we're saving also. Next slide, please. And then finally, some other advantages of river hydrokinetic systems, and maybe to get people, potential partners thinking about how these could be incorporated in their projects or part of portfolios. As I mentioned, there's a potential for very high capacity factors from these projects. I have a case study here, with a capacity of 65%, capacity factor of 65%, which is actually very achievable. And in other rivers, we've been able to secure much higher values. But with if you're taking different forms of renewable energy with the same rate of capacity, a river hydrokinetic system can produce more power for the same capacity with a much smaller footprint than other forms of renewable energy. And this can be an advantage in locations where land is space, and the RivGen system can operate in shallow tidal environments, so it could be very suitable for island environments. But as I mentioned before, actually the combination of a river hydrokinetic system with wind and solar can significantly reduce the overall amount of renewable energy capacity a project might need, and significantly reduce the amount of storage capacity you might need. So moving on to the final slide, and I can wrap up. So my contact details are here. We're very interested to reach out with people developing projects or looking for solutions in areas with strong river flows and strong tidal locations where we think our system could be a very valuable solution to supporting communities and achieving, very high penetrations of clean, renewable and secure electricity. So thanks for your time. Very happy to follow up with anyone who's found this relevant and would like to discuss more.
Oh, nice. Thank you, Brendan, for walking us through this new innovative system. And I'm sure the audience have intrigued with their curiosity, and we'll ask some questions about how to get in touch and how to work with you. Thank you so much. Moving on to the next speaker. And I would like to invite Mr. Seck, Technical Director, H2 Energy, on the floor to deliver his presentation. And dear audience, please do not hesitate to ask your questions so that we can take them during the question answer round. Thank you.
Thank you, Deepak. Good day to everybody. My name is Seck from H2 Energy. We are a renewable energy solution company located in Malaysia, and we focus in implementing energy storage solution based on green hydrogen, targeting the off-grid locations. Yep, next. All right, the technology to generate electricity by renewable sources has been well established. However, the major problem is to have a durable and lasting energy storage system when these renewable sources are not producing, and this one has remained a major challenges to the user in many of the remote areas. In my presentation, I am quoting the renewable source from solar as this is the main source of renewable energies available in our area, right? So as we know that when sun is down, then we need to have other methods to provide the backup electricity. So the most common method is via the diesel generator or via the battery banks. The disadvantage of these two current methods are the generator, of course, we need to pay high cost for the fuel, and being a mechanical device, there's a lots of moving parts and require frequent maintenance and high cost of repair. And also it tends to be less reliable and creating pollution and noise. As for the energy storage, battery-based energy storage system, although the battery technology is improving year by year, okay, we have discovered many locations that have installed the solar battery system years ago. They are facing challenges of failing battery banks, right? And the reason is during the rainy days, the battery bank will over discharge, and then it causes permanent damage. Okay, next. What we are trying to do is to utilize green hydrogen method to use it as a reliable and robust energy storage solutions. This is a typical picture of a solar battery system implemented in a rural location. You can imagine that these four blue bars are originally battery banks. What we are doing is we are replacing them with an electrolyzer with a small interim storage to keep the electronics control running, and we have a long-term storage in the form of gas tanks, and then we have a gateway EMS. The function of this is to replace the existing solar battery system which that has problem with their energy storage currently. All right. The reason is that when company designed the solar battery system, it calculated the solar capacity based on the battery bank. And let's say the user using 100 kilowatt per day, and the reserve battery bank needs to provide 3 days of energy storage, then the solar panel will be sized according to the battery bank. That is 300 kilowatt, 3 times of what the user normally needs. So it creates an opportunity for us to harvest the extra solar energy because of the overcapacity to run the electrolyzer to generate hydrogen gas. And we found that we can extend because we have no moving parts, we have no chemical reaction within the batteries. We are just dealing with physical hydrogen gas. The lifespan of the machines is estimated to be about 15 years. This has been stress tested by the manufacturers, and it also has low running costs and is a cost-effective replacement to the current method. Next. All right, so this is a simple schematic of how the electrolyzer work with the RE input, with water input. Water, we can get it from rain or river, any water source. We purified it and feed into the electrolyzer. The gas is stored in the gas tank, and in the evening or when the sun is down, the gas will be taken out, put into the fuel cell and regenerate the electricity. Okay, next. Right, so this is another illustration, and what I'd like to mention is that all the devices, we have an energy management system to control them via a mobile app. And as long as we maintain an internet connection to the site, okay, we are able to monitor all the devices anywhere, from anywhere in the world. Yep. Okay, next. All right, when we talk about green hydrogen project using electrolyzer, people tends to come into their mind is huge electrolyzer in the factory setup, and it's very bulky. So we fully understood the challenges, and in order to implement our solutions smoothly in the remote locations, we have to design our things to be small and portable. By manpower, we have to imagine that there is no lifting equipment at the site, and every component that we want to move can be carried by manpower. So you can see here that each of the individual equipment do not weigh more than 100 kilos. All right, and then it can be is designed in a plug and play method that can be shipped separately and then assembled at the site. Yep. Next. Okay, and the installation method can be very flexible, right? It can be as simple as a simple fence plus a simple shelter, because we can design the cabinet to be weatherproof, or it can be delivered in a container if there is a lifting equipment or the road is accessible by trailer, right? And in terms of the gas storage, we can build dedicated gas tank, just like the blue one that you see, or we can use standard gas cylinders. It can be purchased from the gas company, because gas cylinders, gas tank, they are all regulated item in many countries, and then this is to enable fast deployment in our project to avoid too much regulators this approval. Yeah. Okay, next. Yes, through our we have a small system currently running in one of the remote village in Malaysia, and we discovered that it is a workable solutions, and we also attract attention from other users, such as the mining company, security forces located in the remote frontier areas, remote island which do not have electricity supply, as well as a telco tower which have their transmission tower located in the area that there is no power supply. So the places of application of the green hydrogen energy storage system is wide and many. Yep. Okay, next. Oh, I think I have reached the end of my application, and we welcome any question from the audience. We will attend to it after the presentation. Thank you, Deepak.
Thank you so much, Seck, for letting us know about the different applications that can be implemented and where green hydrogen can play a pivotal role. Thank you so much. I'm sure, dear audience, you will have a lot of questions for our colleague today. Thank you, Seck. Moving on to the next speaker, may I have the honor to invite Mr. Alessandro Medici, Managing Director, Power-Blox. Alessandro, the floor is all yours, and dear audience, please do not hesitate to ask your questions. Thank you.
Thank you, Deepak. Welcome everyone to the presentation of Power-Blox. Next slide, please. Power-Blox is active in the nanogrid space. So what is the nanogrid? The term is still very new, I think, and it's also not 100% clearly defined. There is some overlapping, as you see in the graph. Mainly what it is like a mini grid, but just smaller. So we start in the nanogrid space. We start even to electrify a few households. So we are kind of in the same space like the solar home systems and the pico solar systems. Why did we create this space? We saw some major disadvantages of solar home system. On one side, that it is very fixed from the services, on the other side also from the investment per household, and then the affordability for especially tier 1, tier 2 households. So we saw that there is an advantage if we combine multiple houses together. It starts even if we connect 3 or 10 houses together, the energy requirements start to balance. So the power start to balance because not everyone needs the power at the same time. That is an advantage because it can feed in with a system that is centralized then in one of the houses and feeds over a small grid to these houses. And it is also overlapping to the mini grid as we see. Next slide, please. We start our nanogrids nevertheless not on the DC side, but also with AC equipment. Why is that so? We see that it is a very dynamic process of electrification. So energy consumption, when we start probably with tier 1, tier 2, but over the time it shifts to tier 3 or tier 4. So we have to also design the system in a way that it is very flexible and can scale up. And that's why we did it on the AC. What we can do is we can start with the nanogrid, and if they grow over the time, because we get more houses, because people, once if there is electricity, we see that they move into the village, and so the village grows, and sometimes even the grids grow together and build then after a while even a mini grid. And that's where we change then in another technology. We go then to the containerized solution of Africa Green Tech. That is our implementer also in whole Africa. So we shift to the mini grids and use the Power-Blox then in another site. And then over time, even the mini grids can be transformed into the public grid. And we have no technology break on the way. So we can really electrify from the nanogrid up to the public grid. At the beginning, we did everything as a service. So the business model mainly was energy as a service. What also created some challenges, especially for the tier 1, tier 2 customers. So really the lower end, sometimes even there, the tariffs we had to use because we had to invest in cabling, in metering and everything was too high. So there we even created a new innovation that we see. Next slide, please. But to fulfill the requirements for a nanogrid, we saw we have to really invent the wheel. So what we created is a very new and patented technology, the PBX200 here as a product, where we put everything in a box. So underneath there is a lithium iron phosphate battery of 1.3 kilowatt hours. And on the upper part, there is the whole electronics that directly delivers this 230 volt AC single phase power and can be connected to a solar module. So we have everything integrated, the MPP tracker, solar charger, grid charger even, and all monitoring equipment that is needed to run the device. And as such, it can run as a standalone system. But the real innovation is now that we can combine multiple devices together. So if, for example, if we electrify a small business and its business runs very well and he needs more power at over time. We just connect multiple devices together. They can be connected via an AC cable on the back. And with connecting two devices or more together, they create an energy swarm. So these systems build like a bigger system and also act like a bigger system. So you have more power, you have more battery, you have more solar because each one has its solar module. And with that, you can create a bigger system. And the good thing about it is because we are in the really rural area, there is no configuration or engineering needed. It's really just plug and play, so plug together, switching on. They only have an on and off switch, no configuration, nothing, and then they synchronize and build this bigger system. So scaling up is very easy and can be done by normal electricians and without special knowledge. Next slide, please. So here you see a typical scenario how we work with. So we start really as probably as a standalone system or building this small nanogrid. Then we can transform into the mini grid and then even to the national grid. We see from the 600 million people that are still unelectrified, we see around 1/3 that probably might be electrified by the national grid, and then 1/3 probably by mini grids, and the rest by nanogrids and solar home systems and pico-solar solutions. So there is quite a lot part of the unelectrified people that really have to be electrified there. And the big advantage that we see now with the nanogrids, that as we see with a solar home system, normally in average, the price per household is around $100. And we see in the nanogrids, we can even half that or even lower than that. So with $50, we can electrify a rural household on a tier 1, tier 2 level, and even at the same time electrify a small business. How we do that, we see then on the next slide. No, that's something in between. So here, just something to add is that we even combine that with so-called direct drives. You probably know the technology from solar pumps. So solar pumps without batteries that are just run on solar modules, then the solar energy is directly converted into a mechanical energy in the pump and then can pump water. But the same technology also works for post-harvest processing, for cooling, for example, without batteries. So we combine that with the nanogrids. And what we do is the excess energy from the direct drives we use in the nanogrids. With that, we can even daytime consumption, we can level up based on that, because probably the pump is not always running or the post-harvest processing is not always running. So this energy can then be fed into the nanogrid, and we, especially for productive use, we can exceed the energy with that. Next slide. That's how we now innovated the new model. So if we think back of the first slide I showed that we did energy as a service model, we saw in some cases the tariffs we have to calculate there are too high even for these very low end customers. And there we now switch to a lease to own model in some cases. So we provide a Power-Blox to a small business on a lease basis. They do a down payment and then a monthly payback. They run their core business with it, for example, mobile phone charging. So they have 20 charges, for example, per Power-Blox. And then as a second part of their business, they electrify the neighbors, and they normally connect up to 20 households per Power-Blox. For that, and then they charge, they create their own tariff models. So we don't force them to any tariff, they do it by themselves. And in average, from the different projects we saw, normally they calculate around $2 per household a month, and that's very affordable. But what they use for that, so they just supply one energy bulb, so one LED bulb with 9 watt or 5 watt, and they don't run it all the day. So they just provide electricity for around 5 hours. But that can also change over time based on their tariff models that they create. So we reduced what we do ourselves and let them design their tariffs. Next slide, please. Here is a sample from Ethiopia, where we electrified around 50 small businesses. They now charge 1,500 phones a day. And besides that, they electrified 620 households with their Power-Blox. The good thing is the lease to own model works very well. So till now, in 1 year, they even paid back. Now it's 89%, more than 98% till now. So almost all is paid back. And you see what they run, so different kind like photo charging, DSTV, sound systems, so many different things they run in the small businesses as application. Next slide, please. Just some photos here from this pilot project. You see barbershops, even health center use it, video halls, charging stations, and so on, grocery shops. So there are many different applications where they use this model on the lease to own basis. And that's it from my side. Thank you.
Thank you. Thank you so much, Alessandro, for sharing us with the journey between the nanogrids to mini grids, and then how it can be transformed to the public grid. And this is, of course, a long-lasting questions in our sector. Basically, what happens when the grid comes, etc., which I will pose when the question answer round starts. All right, moving to the next speaker, please. I have, last but not the least, to invite Mr. David Smith, CEO and founder, Enee.io. David, the floor is all yours. Please start. And dear audience, please do not hesitate to ask your questions. Thank you.
Yeah, thank you, Deepak and team for the invite today, and thank you for the vast majority of people still staying on to hear my presentation. So I'm specifically here today to talk about how the Enee system is being used by CNI customers in Africa specifically, but also in other regions, to change the way that they plan and maintain their battery assets as part of their energy systems. Next slide, please. So what Enee have done is designed the industry's first fitness tracker for energy systems used in areas with an inadequate grid supply. So it's a plug and play system that's specifically designed for the regions with inadequate grid supply, and through our system the user can typically expect to reduce their energy bills by up to 10%, increasing asset life by 40% or more, and we look to give the user an ROI from using our system of 6 months or less. Next slide, please. Thank you. So just to sort of go over the reason why we're here, the problem that we're helping to be part of the solution to, and one problem that everyone on the call I'm sure is fully aware of, but there's over 1 billion people globally who suffer from power outages daily, over 3 hours of power outages a day. In some regions, we're very much focused on Nigeria at the moment. 3 hours of power outages would be a good day for those guys. 7 hours, 10 hours would be typical. In these regions, if you want to operate a business or a home 24/7, then they turn to fossil fuel powered generators, so petrol or diesel generators, to fill in the gaps when the grid's not there. But these are highly expensive and polluting both globally and locally. So more and more what people are turning to are the addition of batteries and renewable power, because it is a green solution and obviously long-term a more financially viable solution. But what we find is these systems often built ad hoc, and we're talking about the smaller scale systems, so not your mini grids, solar farms, wind farms, but your smaller systems. They're built ad hoc with a lack of monitoring, which means that any inefficiencies or issues that creep in over time go undetected. That these add up and can cause system failures. They increase the cost of the energy, increase maintenance costs, and ultimately reduce the confidence in renewable power systems. So the user buys into renewable power as being the savior, and the experience is often not that good, and yeah, they get disillusioned with it. Next slide, please. So our system and why it's unique. So if you're talking about mini grid solar farms, that end of the market is pretty well served by companies providing monitoring. They typically take the data from smart assets to aggregate that data for the user. But in the smaller market, the mass market, and there's 20 million generators in Nigeria alone, no one's really come up with a viable monitoring solution for that type of market. So we've designed a very simple plug and play IoT-based system that is technology agnostic and bespoke. So we don't care about the age, the make, the model, or the setup of an energy system. We can monitor it. And that's quite liberating for a lot of companies, especially with multiple sites where they've built up their energy fleet over time and they've got a different brand of inverter or generator on every single site. They don't need to worry about that. We can come in and monitor it for them straight away. The data is available locally on a mobile phone, or if they want the web experience, then we have a gateway that sends the information up to the cloud, where we have our own advanced algorithms running to provide the information that the user needs to better manage their energy assets. Next slide, please. Thank you. So the important thing is we are more focused on people who have multiple sites. We have a centralized dashboard that can provide them with the overview of their entire energy asset fleet. So we don't care, if they've got 5 sites or 100 sites or 1,000 sites, they log into a single platform and be able to view them all. Next slide, please. So the specific feature we're focused on today, and we can monitor the whole energy system, so the generators, the inverters, but we're focused on the state of health feature that we've launched recently. So what this does is allows the user to understand what the health of a battery is relative to the usage. So we have our own advanced algorithms that run. We base this on what the design of the battery was compared to what it is today, and use that to calculate a remaining health calculation. Then we look at the actual usage of that battery to predict how much longer that battery is going to remain. So this allows on a very high level for users to focus in on the sites where the battery performance is poor, and then through the more advanced analytics that we have to then identify the issues with that specific battery bank. Next slide, please. So just a quick case study. So we had a user that had a relatively new battery bank. It was only 4 months old, and the state of health alert that we have notified them that there was a significant decrease in the state of health, where you'd be expecting up to around the 100% mark with such a new battery. It had dropped significantly from that point. And we then used the analytics to identify the cause of that problem, which was that the battery was being constantly overcharged. So once the battery was fully charged, this is a lead acid battery bank in this case, once the battery bank was fully charged, the charger would remain on boost charge, and in effect cooking the battery, so putting too much energy into the battery. And we early on identified potential dry out. So next slide, please. So by identifying that issue early, we allowed the user to take the corrective action to correct the charger settings that they had, so they were incorrectly set up. And so they changed those settings, and we predicted that we'd increase the life of that battery bank from 2.1 to 4 years based on their actual current usage, which is an estimated saving of over $4 a day in battery life. But also importantly, this site was running a generator as well, and all of that overcharge in the battery was going to wasted energy. So, there's increased environmental pollution as well, but importantly to this customer, they were spending over almost $2.50 a day in excess of the energy that they needed just on the diesel generator, providing them with a total saving of $7 a day. So this battery bank was 48 kilowatt hour system, around $9,000. But because we were monitoring from when the bank was new, we were able to pick up this fault very quickly. Otherwise, in another year, 18 months, that bank would fail. Too late to take any action. All those savings would be lost, and the customer would be none the wiser of why it had happened. Next slide, please. And just a little bit of information on our current roadmap. So we've got a live product today that we're actively selling. We are focused on Africa, but we're also active in India as well. And we've just started a new project, which is the application of AI and machine learning to the data that we already collect to improve our alerting system to give the user the information that they need as early as possible, to be able to, for them to be able to take corrective action. And also the next round of development that we're currently undergoing is where we actually take all the data that we've got, as well as bringing in data from other sources such as the cost of grid power and diesel costs, to provide the customer with the actual live cost of energy for their system, which would be an industry first. Next slide, please. If we've got it right, I think that's the last slide. So thank you very much. Interested if anyone's got any questions, but always feel free to reach out and contact me on LinkedIn as well.
Thank you. Thank you so much, David, for walking us through how data-driven innovation can play a pivotal role in the mini-grid space with energy storage as a backup. Thank you so much.
Thank you.
Okay. All right, now may I invite all the speakers to kindly turn their cameras on so that we can enter to the audience Q&A. And dear audience, if you still have any questions, please feel free to post them using the question answer round. All right, so let's start with the question and answers. Now I would try to follow the same order, but it is not necessarily so that we will go by it, but let's start with Norbert. Norbert, the first question goes to you. Are the kite systems separated from each other by enough distance so as to not entangle into each other when they fly?
Yes, we need a distance between the systems. For the moment, we calculate with 400 meters between two systems that can be closer to each other in the future with a new flying algorithm. But for the moment, 400 meters between the systems, yes.
Thank you. Moving to Quentin. Quentin, do you have a criteria when selecting a country, and what is the guarantee that you request for the financing?
So as I mentioned, we are working with money from the European Union, and so we're working with national budgets. We are in constant discussion with many different delegation of the EU in the country, and we set up budgets where and when it's identified as a priority by the EU. So that's how we select the country in a sense. Do we request guarantee? It depends very much on a case-by-case basis. It's not always requested, but can be part of the financing structure. Yes.
Okay, thank you. Looking at you, Brendan. So there's a question. If I compare the advantages between solar, wind, and hydrokinetic, I see that the last is most advantageous. Can you please share the comparison related to the cost of the equipment used to produce the electricity?
Sure, yeah. So the cost, and I think we discussed this with some of the other panelists as well. At the moment, we're moving from a situation where we've had a number of one-off projects, and we're scaling up our project pipeline to have increase our manufacturing base and move to serial production of our units. So at the moment, our cost is higher than those other forms of renewable energy, and that's why we think it's a good complement rather than a direct replacement. But we do have targets for reducing the cost to much more competitive levels. Although in the markets we're accessing at the moment, we see our cost of electricity being cheaper than the diesel we're replacing. So obviously we want to increase the number of deployments, which is going to help us reduce our costs as well to a level that's more competitive than with wind and solar.
Yeah, right. I mean, especially when we always, whenever we talk about the renewable energies, the first thing comes is the cost competitiveness, because the fossil fuel-based electricity system, they're just so easy and accessible. And when we talk about the renewables, we always think of the intermittency and other problems which are associated with it. Thank you so much, Brendan. Following to Seck. Seck, the similar question comes to you as well. Everyone is curious about your hydrogen system, which is why the question comes as you mentioned about the system is very low cost.
Yes.
Do you have a cost calculation comparison for the equal systems of battery and hydrogen?
Yes, we do. we have do the study based on the lifespan of 15 years, with comparison to 3 cycle of battery replacement, right? And we can prove that our system is more or less having the same LCOE. However, we save the user from the headache of the underperforming energy storage system and the hassle to replace them. Many of our clients are government agencies, and there is problems where they do have the funds to develop the project. However, when it comes after it is running and it's come to replace the battery, they always run into budget shortage. Or it is always easier to ask for fund to develop a brand new project than to ask for additional fund to do the battery replacement, right? So not just the advancement in the in terms of the cost, I will say that in the long run, we have to compare it over the years of the lifespan of the machines. Yeah.
Okay, thank you so much. Then the next question is, it can be a follow-up question to you, Seck. Maybe I can ask you to be online again. So what is the initialization time of the hydrogen system? And would it substitute the battery system from the initialization point of view? So the starting period.
Starting period.
The starting period until the run up to the full system operation.
You mean how fast we can implement the solutions?
No,
or
perhaps
how fast
the operation.
Start operation.
Yeah. Yes.
Yeah. Yeah. Okay, because our focus is one of the topic of the focus today is to replace this green hydrogen as a method as a possible solution to replace existing battery bank. So okay, we have to we see it as based on the assumption that the current solar generators infra it is working. Okay, that's number one, right? That means that the electricity that we get from the existing solar panels they are working fine. So okay, because our equipment are plug and play, so once this is put at the site and we hook it up to the power supply, it can start producing immediately. And because we are dealing with physical media of hydrogen gas, there is no issues of voltage, current compatibility issues. So once the gas is produced, it will be piped to the gas cylinders or the gas tank. And then subsequently, it is, let's say the regeneration via the fuel cell is also, we can tap on the existing DC bus that they already installed, go back to the same inverter and output to the user via the AC bus. So if you talk about the turnaround, I would say that is within, for a small system, within days. For a medium to large system, probably 1 to 2 weeks, we can get the system up and running.
Okay, thank you. Thank you so much. And next question, then I will look at Alessandro. Well, Alessandro, the question comes as nanogrid, minigrids, which is clearly present, the size of the generated capacity. Could you please put them in numbers? What is it in kilowatt or megawatt? And this is a question which I have been receiving ever since I came into the sector, even during my studies, and there is no definite answer for it, I know, but in your terms, what would be the numbers then?
Yes, I think, you know, we look a bit on it more on the household side. So we say we call it a nanogrid if it's below 200 households. That's a bit what we count. But we also go up to 500 households, and then it's the mixed space. You know, it's too high for a nanogrid and too small for a mini grid, probably because a mini grid I think it really starts at around 1,000 households. So on that. But if we look at that from the numbers, we go with our systems up to around 10 kilowatt. So if we are at 10 kilowatt level with the nanogrid, then we see that's more already a mini grid. So, but as said, I think there is no clear definition. when I Google it, you find different approaches there. So I think our industry first has to define it. So we have our own, created our own just to deal with it.
Yeah, I think it's how it is, and depending on the solutions being provided by any solution provider or company, and they have their, let's say, benchmark on the size, then and based on that the solutions are provided. But then again, I'm a bit curious about the nanogrid definition of 200 households. Even the households come with different tiers. They are from tier 1 to tier 5 households. How would you compare these households? Which type of households within these 200 households define a nanogrid then?
We go with the nanogrid normally up to tier 3, so not extent of the tier 3, but we are really focusing on tier 1 and tier 2. If you look, this connection of 20 households per Power-Blox, for example, it's really tier 1 and tier 2, or even tier 1, because normally what our small businesses do with the electrify a household, because they defining that, they just provide. So far, they just provide one LED bulb per household even. Probably they will go up to 3 if there are requests for that, if somebody has 2 bedrooms, for example. And what we also started to do is we don't want to provide them sockets, because as soon as you have sockets, then you also need smart meters. And the smart meter is a high cost component. And they like to just supply them on a monthly basis with a fixed price. So we can also install just USB sockets. So that will be the next thing, that they can install LED bulbs plus USB sockets. Then we are, from the energy consumption, we are quite limited, and we don't need metering. We can do it on a fixed level per month.
Okay. All right. Thank you. Moving to David. David. One thing that caught my attention during your presentation was the centralized dashboard, the centralized system. Now I'm wondering, in off-grid areas where there is, let's say, not enough connectivity to start with, how are people going to be using those, let's say, innovative data-driven, let's say, solutions that you're providing? Question number 1. And a follow-up question is the translation to a layman's, let's say, understanding of your system. I mean, of course, almost everyone is using a smartphone, but then again, how understandable, how user-friendly is your system for a layman to understand and operate and use on a daily basis?
Yeah, so we have different scales of the product depending on who the user is, from a technician or a homeowner, all the way up to a director. So depending on who in the organisation or who's using it, we have a different entry level for them into the system to view the data or to view the information. If we're in an area with poor connectivity, as long as there's some connectivity, the data that we use is very minimal. So it's not a big data platform, as in the amount of data we get per site. It's the insights that we gain from that data that's the important thing. But we do have the website optimized for mobile phone, and in many ways the experience on a mobile phone is much better. So if you're a single site user and you want to view your site, you don't go to the dashboard area. In fact, that's not available. You just go to the site that you're looking at. If you're a technician, then we've got a mobile phone application that is standalone. You don't need to be connected to the internet at all. So if the energy system we're monitoring doesn't have any connectivity whatsoever, you can still get the data live from the monitors and use it as a fault finding tool. So we have considered all the different use cases, and there is a different part of the platform for each one. But if there is zero connectivity, then obviously we can't get the data and you won't be able to use it online, but we do have the mobile phone application for a technician.
Right. And in places where there is no network?
If there's zero network at all, which is very rare, then obviously you won't be able to get the online reporting. We won't be able to get the data for you to view the online reporting, but those cases are rare. And, we are focused on more urban areas as well, where connectivity isn't an issue.
Okay. All right. Then thank you, David. Quentin, what are the interest rates for your funding? Could you share more information on the terms, such as loan period?
Yeah, well, we don't have a fixed type of investment, so we adapt to the market. What we try to do is not distort the market, so we invest at commercial terms. We try to align also with the co-investor that we find. As I mentioned, we are active in very different countries and geographies, so the interest rate is adapted to the risk taking. It's not a standardized approach, so we'll try to find the best instrument and the best features to make sure that the investment is suited for the investment we want to do. We have invested in working capital, which may be very working capital facility, which may be very instrumental to the deployment of certain CNI EPC contractor, for instance, but may not be relevant for others. We invest in equity and in debt. So, well, we don't have standardized terms and conditions or interest rates.
And that extends to also the overall power generation capacity?
Yes, definitely.
Okay, understood. Okay, because there was a question about the maximum capacity that you will start supporting for power generation. So I understand that there is no limit or no scale.
No. Well, the ticket size is probably the limit. So we invest roughly from 1 to 10 million. The sweet spot is 2 to 3 million euro. So it gives an idea of the type of project we can support. We can participate to IPPs like 20, 30 megawatt solar IPPs, but then we'll work as a very subordinated tranche to make sure that the ratio looks a bit better on the senior tranche.
Okay, thank you. Norbert, can you please tell us about the efficiency comparison of SkySail turbines compared to the conventional wind turbines? We are not able to hear you. Are you on mute by any chance?
Now you can hear me.
Yes.
That's always a good question, and at the end, it's not really a fair question, as conventional wind energy has already 40, 50 years of experience, and we just start with our solution. We have the first system itself. We have some advantages. We are easy to transport, easy to install. We need 1 day to install our system. At the end, you can move our system. We also need 1 day to disassemble everything. That's not so easy, as you need a flying permission for the site, but at the end you can move it. That's not possible with normal windmills. We have no shadow from the blades, as we have no blades. We have many advantages against the classic windmills, but I don't see us as a competitor of classic windmills. If classic windmills are possible, please use classic windmills. We are too small, 200 kilowatts. Normal windmills are in 3, 4, 5 megawatts. That is not our system.
Yeah,
we are more in a special market, low energy consumption, 200 kilowatts, 500, 600, 800 thousand kilowatt hours per year consumption. That is our focus for the project, and there we have big advantages. And yeah, at the end, to compare it really with classic wind is not fair. What I can offer everybody who wants to see our system in real, you are always welcome to our site and have a look to see the system in real. We have 2 sites where it's possible, one in Germany in Kriegspühl and the other one in Mauritius. Please send me an email to power@skysails.com. There can we arrange it, and it's possible for everybody to see our system in real. And to give my personal mind to that, it's really impressive to see this big kite flying. 180 square meters is really big.
Yeah, thank you. Thank you so much, Norbert. Looking at you, Brendan, in terms of the scale of your solution, can it be, let's say, scaled down to be used for 1 household? Or it has always to be a community-specific solution?
Yeah, I think in theory it could be. I think we're focusing our product development and technology development at at larger systems or smaller units. It's our modular RivGen system, which could be as low as 17 kilowatts. But again, that's going to be much more than a single household. So we're kind of happy that that's our market size. Again, in theory it could be, and maybe there are other solutions that could work at a smaller scale, but that's not a market we're focusing on at the moment.
Okay, understood. Thank you. David, well, there are many energy optimization solutions available in the market. What makes Enee.io stand out compared to others?
Several things. First of all, from the very offset, what we've done is designed a product suitable to the market that we're operating in. So it is specifically designed for regions with inadequate grid supply. So the simplicity in our system to use, it is very much plug and play, both from a hardware and a software perspective. So you don't need highly trained technicians to install our system or to use our system. It's designed at a level where if a technician's capable of installing a battery, then they can install our system. We're hosting a technical seminar next week to train up people on how to install it, but it is a relatively simple process. The price point that we're able to go to as well is another serious, something we've had to seriously consider given the market. And we are very much, our target market is the smaller end of the energy system market. So we're not really interested in the solar farms and the mini grids, albeit we can do it, but we see that sector as being very well served already. But for the 20 million users of generators in Nigeria, the vast majority of those don't have any monitoring, whether they've only got a generator, they've got grid, they've got batteries, they've got solar. The vast majority don't have anything because of the need of that market to be simple and cost effective and quick to deploy. So that's really, the target that we're looking for. That side of the market is relatively underserved.
All right, thank you. Dear audience, I would like to highlight the fact that we keep the neutrality, which means I also have received some private questions regarding contract cancellations, etc. I reserve the right to not raise them on a public forum like this, but I will be sharing your questions with all the speakers, and if they find that in their discretion to answer you, they will reach out to you. So please refrain from asking such questions, I would say. Anyways, moving on to Alessandro. Alessandro, a similar question regarding the pricing that I asked to other speakers. What would be the typical pricing of a Power-Blox system, please?
Yes, well, it all depends on the quantity, to be honest. We're still in small-scale production, but even what we see on the small-scale production, if we look at the business case, we're half the price on the household level. So if we electrify 20 households and a small business, then we are lower than if we look at the solar home system, for example, pricing. And that, I think, is really the target to go. What we see, it just gets more interesting if we scale it up. And we start with production lots, 3,000 to 10,000 pieces upwards. Then it's when we see it's really interesting, especially because if we go beyond that from the scaling, then we might not even need subsidy, as we see that the paybacks are very good, as we are focusing on business to business, not on business to customer. That's the interesting fact of it. We have 1/20th of the operations cost as we serve the small business, not the end customers, because the end customers are served by the small business and they're doing everything. And over the time, we might come with additional equipment, a lot of digitalization and so on, but that will increase the price. So we're really happy with the level we have and this really simple way of electrifying the neighbors around it. I think that's where we focus on to scale up. So mainly, yeah, it's really a question of the numbers what we can reach on scale in the next years.
Okay, thank you. So being mindful of the time, Seck, I have a last question for you. The question goes like, I would like to know the sizing of the system that has been installed in the village in Malaysia. Can you kindly share the sizes in kilowatt hour, please, if it is possible?
Oh, all right. The size of the current system we have is about 40 kilowatt hour per day. But it's still in we are still in the evaluation phase, and then it is possible to scale up to whatever wattage that the user may require. We just need to add more gas storage or add the panel capacity, and it can be scaled up or scaled down anytime. Depends on the user's needs.
Okay, thank you so much. All right, ladies and gentlemen, we have come to the end of this webinar. I would like to take the opportunity, first of all, to extend our thanks to all the speakers, all the panelists today for your valuable time and contribution to this insightful showcase webinar, which is on renewable energy generation and green hydrogen. As you all know, these are the topics that we strive to bring forward to keep the attention and the contribution intact in order to go forward with our common goal of energy access and green energy transition in the world. Thank you so much. And then I would also like to extend our vote of thanks to the audience for your patient hearing and engagement, as well as asking your questions. I hope that we touched upon majority of the questions. Please do not be disheartened, because I will be sharing the rest of your questions with the speakers along with your email addresses so that they can find it in their discretion to reach out to you with the answers. And at the end, I would also like to thank my organizing team for the support that we have in place to organize such webinars. Moving on to the last slide of the day, which is then the teaser to the invitation of the next I4E Showcase webinar on 5th September 2024. And also, those of you who are interested to meet us in person, please take a look at the Energy Access Investment Forum coming up next month on 21st to 23rd of May, happening in person as well as virtual in Lagos, Nigeria. So see some of you there and wish you a nice rest of the day. Thank you.
Thank you, Deepak.
Thank you.
Thank you.
Thank you.
Bye.
Thank you.
Bye. Thank you.
Bye, everyone. Thank you.